Hi, my name is Davor and I'm a Master of Education student here at UBC. Today we're going to be doing some fun demonstrations to do with air pressure and suction cups. So have you ever watched a movie where a thief is trying to break into a glass case and he cuts the glass, but he needs to remove the glass from the case? How does he do that? Well, he uses one of these, a suction cup, and he sucks it onto the glass and he pulls it away. But how does that work? How does suction work? Well, it all has to do with pressure, specifically air pressure. So what is pressure? Pressure is just some force applied over an area, right? So when I press with my hand down on the table, that is pressure. When I'm walking on the street, my feet apply pressure to the floor. That's what pressure is. But here we're talking about air pressure. We call it atmospheric pressure. Okay? It's pressure from all the air above us in the atmosphere pushing down on us. Now, air is not heavy. We know that. If we have a box of air, it's like an empty box, it doesn't weigh much. But if we put a lot of water in it, it weighs a lot more. So we know water is much more dense than air. So air is not heavy, but we know that there's a lot of air above us. There's a whole atmosphere above us. And there's just so much air there that altogether, gravity pulling down at it creates pressure pushing down on us. And this pressure is actually quite strong, and it's what holds us down. And the important thing here is when we look at the difference of pressure. So for example, if you think about any movies that you've seen, if someone's in an airplane and a door is opened when they're flying, or they're in a spaceship and a window breaks open, you see all the air getting sucked out of the plane or out of the spaceship. But why is that? Well, that's because the pressure inside the spaceship, because there's air in there, was much greater than the pressure outside. In a spaceship, the pressure outside there's no pressure because there's no air outside. It's a vacuum, right? And the same here. On us, when we're down on the earth, there's atmospheric pressure pushing down on us. The higher up we go, let's say we climb a tall mountain, there's less pressure on us because there's less air above us. So what happens with the suction cups? Well, when I push the suction cup down, I'm pushing all the air from inside, under the cup, out. And then when I pull this handle up, I seal the outside so that no air can come in. Now, because there's a lower pressure of air inside the suction cup, it's called a partial vacuum. There's almost no air in there, so almost no air pressure. And there's all this pressure outside pushing down. The pressure outside prevents me from pulling this up. But if I release this handle and I let the air come back in, we equalize the pressure. We have the same pressure outside and inside. And then I can just easily lift this up. Over 100 years ago, there was a German scientist, and he was also mayor of a city. And he wanted to prove to everyone how air pressure worked. He had invented these vacuum pumps. That created a vacuum when the air was pumped out. So again, when we create a vacuum, there's very low air pressure. And what he did is connected two of these vacuum pumps together, and he sucked the air out until there was very low air pressure inside. And he got two horses, one on each side, to try and pull these apart, but they couldn't. And that's because of all the air pressure outside pushing down and preventing these cups from pulling apart. So air pressure can be very powerful. Even though air is not heavy, there's so much of it that the pressure of it pushing down can stop me from pulling this up. Thank you.